Okay, so anyway, that's what that deal is. FRBI. Field R terminal is your stator. Your battery is input, so it'll tell what to do. But now your electronic regulators are the same way. They work pretty much the same way as that. Okay, you got that? So engine supplies mechanical energy to the drive of the generator. The alternator has got a standalone regulator. The generator is controlled by the PCM. Everybody clear on that? Brandon? You clear on that? Brandon's listening to that other thing. Okay. The crankshaft turns approximately 3 times as fast as the generator rotor. That's totally false. How would you know this? How do you know that's nonsense?
Ain't it backwards?
Well, yeah, but I mean, just looking at it, how could you tell it's not right?
The diameters or
Diameter of the pulleys. Somebody show me with your hands how big a crank pulley usually is. About like that. How big is your alternator pulley? Little tiny thing, about like that. Okay, so if this is turning at 1,000 RPM and it's 3 times as big as this is going to be turning at 3,000 when this is turning at 1,000, isn't it? But if this is turning at 4,000 RPM, this is turning at 12. Think about that. That alternator is spinning really fast. I mean, it's cranking up. If you're spinning 5,000 RPM, it's 15. So that alternator is undergoing a tremendous amount of stress, more than you ever think about. All right. Generator, and they're talking generator because of the J1930 folks here. Works on the principle of electromagnetic induction. You sweep a magnetic field across copper windings, it creates juice in those windings, right? Moves current. One disadvantage of an indicator light is that it's hard to read.
Get a point using it then.
That's false. Poor connections in the generator are a common cause of charging system failure. That's true. There's all kinds of connections in the generator. The generator can only be accessed from under the engine compartment. Well, sometimes that's true and sometimes it's not. Like for instance, we had to put an alternator, generator, whatever you want to call it, on the, I'm going to tell you, let me briefly digress here. I wrote an article for Motor Age magazine about alternators, and it was an article for the 13th issue that they published in, I think, 2006. And this one vendor that makes ignition coils and alternators and starters and all this kind of stuff was well, they wanted an article written about alternators to put in there, and you know, so that they could put their tag on it and all this kind of stuff. And so I went ahead and wrote the article, and the guys from the engineers called me and were talking to me about the article I wrote, and they told me, just call it an alternator. And I said, well, J1930 says to call it a generator. They says, we don't subscribe to that hogwash. Call it an alternator. He says, that's what we call it. That's what we want you to do. So I said, okay. And I talked to the guy about how they do stuff different from other rebuilders. You know, whenever they're doing that. You know those slip rings on the end of the rotor? How they had to wear down? You ever seen them where they wear down, where the brushes dragged into them and made them little, you know, tracks in there? They actually measure the diameter of that to see if it can be machined down smooth without it changing the relationship between the brush and the, you know, they do a lot of stuff that regular rebuilders don't do. Okay, but the Ford 500 and cars like that Judy's got, that's got those big, any of those Fords that's got those dual overhead cam sideways engines like an Taurus or something, that alternator has to come out through the wheel well. And it ain't no fun. It's a booger bear. On hers, actually, you can get it out kind of down from the back, but anyway, it's tough. Checking and adjusting drive belt tension is an important part of charging system service. Well, that's a no-brainer. Yes, the generator component most likely to fail is what? Now, you can't have a whole bunch of them most likely to fail, so it's got to be just one of those, doesn't it? That's going to be, well, look at that. All of the above. Say it's a poorly written question. Bearings, brushes, rectifier. I don't see a lot of bearings fail. If you got really, really high miles on one, the brushes wear out, and occasionally the rectifier fails. But alternators nowadays, usually what we see is the stator or the rectifier. Rectifier's got some diodes in it, you see. Takes the alternating current and fixes that, or it'll be direct current. A possible cause for an undercharged battery and slow cranking is A, frequent short trip driving, B, turning on all lights with the engine running, or C, excess use of car phone when the engine is running. Please, what do you think about that? You know, this may be, that's a frequent short trips. We used to occasionally, when we would check charging systems on some of these cars, they would complain that when they drove around town, their battery would go dead while they were driving. And so what we do is we'd hook our charging system machine up, put the inductive amp clamp on it, you know, the arrow pointing away from the battery on the negative side or toward the battery on the positive side, at the battery, not coming out of the alternator, put it at the battery. And we would turn on all the lights, the blower on high, and we might even turn on the wipers. Headlights on bright, you know, the whole, as much current as you would normally use, right? And then we would see which way the current was flowing. If that amp reading starts reading minus while you got all that stuff turned on, while it's sitting here idling, you probably found your trouble. Sometimes alternators can get weak and put out not quite enough, but still put out. You get where I'm going? Like if it's a 130 amp alternator and you check it and all it's able to produce is 60 amps, and you need to put another alternator on it. And some of these people put these underdrive pulleys on there to spin the alternator slower. I mean, they put a smaller crankshaft pulley and all that stuff. And so that causes sometimes the alternator not to spin fast enough, even if it's nothing wrong with it. So there's a lot at work there, you know, that you got to deal with. Anyway, let's see. What's not a major component inside a generator? What is not? Which one of those? Rotor, stator, resistor, rectifier? Is that a major component? Was the resistor a major component?
No.
You know, so that's C. Tests made to determine whether the charging system is operating normally include what? Charging voltage, generator relay test, voltage peak test. That's number 14. All of the, charging voltage test primarily. Not going to be all of the above. I don't know why I said that. Charging system includes a generator, voltage regulator, and system wiring. It's going to be all of those. And finally, number 16, and everybody's glad to be done. Today's charging systems use a what kind of generator? Is it AC, DC, AC-DC, or all of the above? That's a B. It's actually, it produces AC current, but it's rectified and turned into DC current.
Number 9.
Number 9. All right. Number 9. Let me get number 9 up there. Number 9. Did I bypass number 9 and jump over it? The only complete test of a generator is the current output test. What do you think, guys? That's true, isn't it? You can usually tell if everything is like it's supposed to be on most cars by just measuring the charging system voltage. But you need to be able to check current output before you can absolutely tell. And that's done with an inductive pickup. You can actually do it with a scope. If you put your inductive pickup on the alternator and you know, look at your scope, it ought to go down and then come back up, and you get a voltage over time thing, you know, that way. So, that it? Everybody through? This is Electrical Systems Test 4. And so what we're going to be looking at here is chapter 4 in that book. Part numbers for a generator or a regulator are usually the same. Is that true or is that false? Part numbers for a generator and a regulator are usually the same. Are you confused? Huh? Yeah, because if they were the same, then they'd be the same part, wouldn't they? Is that silly or what? All right. Now then. All right, let me prepare for my next question here. In order for the charging system to supply all the current needed for vehicle operation lights and accessories, the engine must be running. Well, does the charging system work when the engine is not running? I don't think so. Right? All right, you got that? Okay, question number 3. The engine supplies the mechanical energy to drive the generator. Yep. Now, what's the difference between a generator and an alternator? You've all heard this thing called an alternator. I've already charged our battery. Brandon, you should know the answer to that. What's the difference between a generator and an alternator? I mean, why do you call some of them an alternator and some of them a generator, even though when you hold them in their hand, they look just alike?
This alternator, let's see. Generator generates energy and alternator alternates. Something like
That
that.
wasn't the answer I was looking for.
I'm trying to remember.
The reason, remember this, because as a parts person, you need to know this. The generator is the name that the federal government, the J1930 regulation, wants us to call the charging component the generator if the PCM controls the field. If the PCM controls the alternator field, if it, the part that spins in the middle, how strong that magnetism is what determines how much it puts out. And when you increase the current that's flowing to that field, the generator is going to put out more. Now the PCM controls that on some, and some, like on our little Ranger, have got a got a voltage regulator that's built on. Now look at that on the wall over there. You see that part right there? Now that rotor that spins inside is right here. That part right there is a voltage regulator like they used to use back in the 70s. And whenever that thing, you have what you had on that thing, this is electrical, so there's some things I need to tell you guys. I used to wire those up. On forklifts, I'd put a General Motors alternator. Sometimes I'd pull a generator off. I'm talking, when I say a generator, I mean a big old long generator like I used to use in the early 60s. And that regulator on a Delco system was FRBI. It's really something that I've remembered that for over 30 years, isn't it? FRBI. All right. On your alternator, you basically had your big terminal coming out, and you had two wires here, right? Okay. One of them was the R terminal, and one was the F terminal. Okay, so on that right there, this went here, that went there, and this right here went to the battery, and this right here went to ignition. But it went through the light to power. So this goes through the light to power, that goes through B+, and that B+ wire is how it looks at the charging system, see what's in the battery, so it'll know whether to extend more field up here. Okay, the field is actually a ground that's fed to it through the mounting tabs where it's mounted to the car. So the field terminal controls how much current it puts out. The R terminal is what? What do you think that would be for?